Problem 6 from exam number 6. Problem 6, I give you a box. The box is 2.5 kilogram and the box is accelerating on a body number 2. So let's call it body 2 and let's call this one body 1. And is accelerating this direction with 2 meters per second squared. Because someone is applying 15 Newton to the east, so therefore is accelerating to the east. That's fine. The problem is, how can you find the force of friction without knowing the body 1 and body 2? You don't know them. So it's probably, you think, is an impossible task to overcome. Well, because the body 1, you knew body 1, body 2, you would be able to find the mu k, and you would be able to say, hey, ff is mu k fn, and hey, you know fn is 25 Newton, and you put mu k and you know the friction. But this problem is actually not that complicated. It's the easiest problem in the test. Because, hey, Newton's second law. So what do you know about Newton's second law? F equal to ma. You put all the forces that acting, they ask you to force of friction, so you must be writing force of friction at the opposite direction, and this arrow must be smaller because you're expecting a smaller value than 15. Why is that you're expecting a smaller value than 15? Is because this box has a net force to the east. Therefore, this box is accelerating to the east. So that must be smaller. If this is the smaller, then there would be a net force to the east. Okay. So Fa minus Ff is equal to, what is the m? 2.5. And what is a? 2. So you write Fa minus Ff is equal to 5. And Fa, you know how much? 15. So Ff is 10. Or you can bring 15 minus 5 is Ff, sent over there. So Ff is how much? 10 Newton, of course. So you write 10 Newton. Now you exactly know what is the net force. Net force is 15 minus 10, which is 5 Newton. 5 Newton is the net force to the east. Therefore, the box is accelerating 2 meters per second squared. You can check it. 5 divided by 2.5 is 2. Again, you should not compromise your understanding. You should try to solve the problem and try to understand the different aspect of the problem. This problem is what location this problem falls under. Of course, right here, location 3, because hey, acceleration is more than 0. 7 is the area under VT graph. As you know, area under VT graph is displacement, okay, and area under speed versus time graph is distance. Just it's a related idea. And absolute value of area under velocity versus time graph is also distance. So I'm gonna give you a graph. This is how I created, and I'm gonna call this one velocity, which is the y-axis, and I'm gonna call this one time, which is x-axis. And maybe I'm gonna give you total trip is, I believe, 8 seconds, 2 seconds, 4 seconds, 6 seconds, and of course 8 seconds. I'm not drawing it to the scale. So 8 seconds, 2, 4, 6, 8 seconds, is the total trip. And total, the minimum velocity, let's say, is 0, and maximum velocity, let's say, is 15. Okay, so maximum velocity is, let's say, 15. So we don't need that. This is my x and y coordinate, and let's say minimum velocity is 0 and maximum velocity is 15. Let's say from 2 to 4 from 0 to 2 second, object accelerates, I don't know, accelerates 5 meter per second square, right? Object accelerates 5 meter per second square at 0 to 2 second. 2 to 6 second, object acceleration is 0. Object acceleration is 0 from 2 to 6 second. Object acceleration is 0. From 6 to 8 second, object acceleration is, let's say, 2.5. Alright, however, that's not what I asked you to do. I asked you to find how much displacement between 0 to 6 seconds. That's all I ask you. So 0 to 2 second, you have to find the area under the curve. So you're going to write half BH. And of course, 2 to 6 second, you're also going to have to find the area under the curve. And since this is a rectangle, you're going to write BH. So half, this B is 2 minus 0, and this H is 10. This B is 6 minus 2. This H is 10. 10 minus 0. So 10 plus 40, which is 50 meter. And what is this total area represent? Of course, displacement. You can also think of distance, because if you take the absolute value, this becomes speed, and this you call distance. Of course. Then you remove the arrow. Please pay attention to every problem. Try to understand all dynamics of every single problem. You can say this is location A, location B, and location C in a friction graph. Right? A is of course at location, this location. B is of course at this location, and C is of course at this location. Try to understand every aspect of every problem. So that means it gives you satisfaction though. A person start walking from point P, walk 2 kilometers, and then make a 90-degree angle, walk 1.4 meter to the, of course, east. What do you have to use? You have to use a protractor to find the angle of the resultant. So let's construct a line that represent 2 kilometers. So this is, let's say, 2 kilometers. 20 centimeter is the 2 kilometers. So this is 2 kilometers to the east. And let's draw 1.4 kilometer, and let's say this is 14 centimeter, and that represent of course 1.4 kilometer. Notice that this is already, I gave you this problem already in head and tail. So you have no problem drawing the resultant. You're going to draw the resultant by, of course, connecting the tail of vector 1 with the head of vector 2. This is the resultant. As you see, this is the resultant, because I already put it in head and tail, head of vector A and tail of vector B. Okay, you have to use your ruler, otherwise you're not going to be able to use the protractor to, of course, find the angle correctly. Then you have to use the trigonometry. Trigonometry give you a more precise answer. Make sure you put an arrow at the end of resultant vector. Okay, this is what the angle we use for parallelogram. Please understand that this is the angle we use for parallelogram. This is the angle we use for law of cosine. So when we talk about a squared is equal to b squared plus c squared plus 2bc cosine theta, then we use this angle. When we use law of cosine, a squared is equal to b squared plus c squared minus 2bc cosine theta, and tail give you the angle for the resultant. So let's find the angle of the resultant by using a protractor. You have the protractor, okay, so you're gonna, there is a line on the protractor, and make sure you align this to the dot over here. So I'm going to align it to the dot over here, and what I see over here is as you see, this is 0, by the way, this is 0, and there is a dot in the middle of the protractor. Put the dot and the 0 align on the x-axis and move. I see 10 degree, I see 20 degree, I see 30 degree, and I see 35 degree. So this is what I see, 35 degree. 35 degree. Since I measure it by hand, I'm not sure whether it is actually 35 degree. I have to write 35 degree plus minus 2 degree. However, if I do the trigonometry, then of course I'm 100% sure. So for example, I'm going to use SOHCAHTOA, SOHCAH and TOA. I'm going to use all three to find the angle. So let's find this one. If this is 2 and this is 1.4, what is this one? And this is 2 squared plus 1.4 squared is equal to 2.44. 2.44131123. All right, so law of so the sine, let's do sine over here. So sine theta is equal to opposite is 1.4, and hypotenuse is this one. I'm going to just write 2.44, and theta is equal to inverse sine 1.4 divided by 2.44. And I'm going to come over here and I'm going to write second sine 1.4 divided by 2.44. I hit enter and I see exactly 35 degree. So there is no error to this one. So my answer would be of course 35 degree. I don't have to write plus minus, but every time you see that they ask you, I ask you to solve a problem with protractor, you use calculator just to verify your hand measurement. You don't have to let me know that you use trigonometry. You don't. You just verify. This is for yourself own satisfaction that your measurement is good. There is nothing wrong with car. Cosine theta is equal to adjacent. Adjacent is 2 over, of course, hypotenuse, which is 2.44. Theta is, of course, cosine inverse 2 over 2.44. I will let you check this, but I know this is 35 degree. You can even improve your confidence by doing it using this way, because there's nothing wrong with that one as well. So tangent theta is equal to opposite over adjacent. So theta is equal to tangent inverse. Opposite is 1.4 and adjacent is 2. And again, I'll let you do this one. All right. You should do it all different way to satisfy yourself. And again, you also want to do, you don't want to solve this problem, because the next time I probably ask you the same question, but I ask you solve this problem using parallelogram. So what are you going to do? You're going to be creating the copy of this one over here, and the copy of this one over here, this is of course 1.4, the copy of this one over here, right? Okay, so this one is arrow is this one, and this one is arrow, of course is this one. Okay, so now when I said that you have to use I was wrong, for law of cosine you have to use this angle. This angle is head and tail, so you have to use head and tail for, of course, law of cosine, and you have to use the tail and tail for parallelogram. Also, you can use head and head for law of a parallelogram, and you can use head and tail for law of cosine. Use the law of parallelogram, you either use tail and tail or head and head. When you use the law of cosine, you either use this one, which is head and tail, or this one. I'm going to go over problem number 9. You see that problem number 9 from the test is exactly same as the assignment 46. Problem number 9, you are 50 meters above the ground, minding your own business, and I use this analogy. I don't know how to draw a gun. I use this analogy, that is, all of a sudden Mr. Berry attacked by a terror, so Mr. Berry decided to jump in a hope that he will land 90 meter away from the base. So this is base, so this is the building base, so that he can land on the river. And this is of course concrete. He doesn't want to land on concrete, because if he land on concrete he will die. So his main goal is to land on the river. He's jumping from 50 meter tall building because he is chased by a terror with the gun. This is the same problem as I sent you the tutorial for problem 46 last night. We set up a lab, and we roll a tennis ball. So tennis ball roll from an incline, so it gets some velocity. It gets to roll on the x-axis, and then it has some horizontal velocity, and its y component is 0, and its land 60.60 meters away from the base. It's not 99% same, it's 100% same. We solved this type of problem in the class before. You must understand at location A what is happening at location A. At location A, or location 1 you can call, and location 2. At location 1 you have Vx and Vy. Vy is 0, and Vx you're going to find it. How? You know, Vx is dx over t, and that's how you're going to find it. So the problem is just like the assignment 46. So dy is equal to Viyt plus half Ayt squared, and dx is equal to Vix plus half Axt squared. Notice that this is acceleration due to gravity, so this is a negative 10. Notice that this one is 0 because this is 0. Notice that this one is negative 50 because this is negative 50. I brought it last week from Amazon so that I would be able to use it for tutorial. So minus 50 is equal to minus 5t squared. As you see, t squared is 10, so t is 3.2, I believe. So square root of 10 should be 3.2. All right. Now you also notice that you know dx, right? You know dx. Dx is 90. Very nice. There is a t missing. I believe you notice I intentionally didn't put it. You also know acceleration due to gravity at the x direction is of course 0. And you know t is, you already found, 3.2. So Vix is equal to 90 divided by 3.2. I believe it's 28. So 90 divided by 3.2 is 28 meter per second. So to land on the river, Mr. Berry has to jump with more than 28 meter per second. If he does not, then we will be landing on the concrete, which should be similar to problem number 10, which is also similar to the assignment number 46. So problem number 10, I have, it's the same problem. The building is 100 meter, and there is a river 60 meter from the base. 60 meter from the base, and this is 20 meter. This is 20 meter long. Mr. Barry is here. Okay, and then this is, again, I'm going to put the same scenario over here, and Mr. Terry also over here. Actually, they are on the same rooftop. However, I have a different setup because I want to show you the problem separately. This is 100 meter. So all of a sudden, the terror opened the door, and the river is again exactly 60 meter from the base. All of a sudden, the both guy, Mr. Barry and Mr. Terry, they are discussing about the World Cup soccer, whether the France win or the Argentina were doing. All of a sudden, the terror attacked them. Understand that this is exactly the one we did last night. Roll a ball, the ball roll and get dropped over here, 0.60 meter from the base. You should do this lab. This is so important. To understand it, to appreciate it, you must do this lab at home. Of course, we do things at school, but at the same time, you're going to have to do the things at home as well. As soon as the terror chased Mr. Barry, he is 100 kilogram, and this guy is 50 kilogram, Mr. Terry. So Mr. Barry, of course, want to save himself from the terror, so he started running with constant velocity. It took him 2 seconds to get here and finally jump in a hope that he will land on the river. But where he will land, that's what we're going to find out. Whether river or on the concrete. So his initial velocity, Vx, we'll find that. Vx is very easy to find. 20 divided by 2 is 10. And Vy is 0. Now let's find the time. Well, we can do both at the same time. His horizontal velocity, he spent 1.45 second. So 20 divided by 1.48 is 13.8 meter per second. And this is 0. So what I'm going to do, I'm going to write D. I'm going to write Barry. I'm going to write Terry. Then I'm going to have dy for Barry, dx for Terry, dy for Barry, dx for Barry, dy for Terry, dx for Terry. Tree diagram. VIYT plus half AYT square. VIXT plus half AXT square. VIYT plus half AYT square. And VIXT plus half AYT square. Now guess what? This is 0, this is 0. This is negative 10. This is of course 0 for Barry. Why? This is 0. This is 0 for Terry. Why? Because this is 0. This is negative 100 for Barry. This is negative 100 for Terry. So what do you have? You have 5t squared is equal to 100. So t squared equal to 20. So you have t squared is equal to 20. Of course, 4.5. And again, this time we're going to find t also 4.5, right? So t is also 4.5. So what do you think? For Barry is 4.5. For Terry is also 4.5. So both men will be able to land on the river, right? Not really. The range depend on not y. The range does depend on x. So what do you expect? Mr. Terry's range would be higher than Mr. Barry for the region that you see over here. And let's verify whether that's true. T for Barry is how much? 4.5. And T for Terry is 4.5. All right. However, VIX for Barry is 10. And VIX for Terry is 13.8. So Barry gonna be landing on concrete. Unfortunately, Barry wanna land over here. However, he will be right here. Okay. So the Terry would be landing on the river, which is 60 meters away from the base. And 62 is right here on the river. 62 is right here on the river. So again, this is how you should be able to solve this problem. So make sure you do lab number 46 at home, a projectile motion lab, by rolling a marble or a tennis ball from an incline. You can create incline just like I did. And you place a ruler. You don't have the ruler, that's fine. You do a slow motion. And then take the distance by using anything. By using the small ruler.